Have you ever wondered about the mysteries that inhabit our solar system? A cosmic enigma, a planet that defies expectations, a fascinating world known as Venus. Get ready to embark on a journey filled with discoveries and surprises as we explore the secrets of this enigmatic planet. Join us on an expedition through the unknown and immerse yourself in a universe of scientific curiosities that will leave you in awe. Imagine a place where clouds are made of sulfuric acid, temperatures are able to melt lead, and atmospheric pressure is suffocating. This is the world of Venus, a place that defies all our expectations and makes us question what we really know about life in space. In the midst of a hostile and extreme environment, Venus holds intriguing secrets that defy the limits of our understanding. Get ready to be amazed by surreal landscapes and unique phenomena as we venture to this planet that intrigues us and makes us question our own existence. Venus, the second closest planet to the Sun, is a world shrouded in mystery and contrast. In this exciting exploration, we will delve into the layers of its dense atmosphere, unravel the secrets of its volcanic surface and be amazed by its complexity, revealing how this planet, although similar in size to Earth, is a fascinating enigma that challenges us to understand the diversity and complexity of the universe. Venus, known as the second planet from the Sun, possesses unique characteristics that distinguish it among the rocky bodies within our solar system. It boasts a solid surface and possesses the densest atmosphere of all the rocky planets. Notably, its mass and size are remarkably similar to those of its neighboring planet, Earth. In its orbit that lies closer to the Sun than Earth's, Venus consistently appears in our sky near the Sun either as a brilliant morning star or a captivating evening star. While Mercury also shares this pattern, Venus stands out more prominently due to its extraordinary brightness, surpassing all other star-like planets and fixed stars. Throughout history, Venus has held great significance for human cultures and astronomy, owing to its prominent presence and celestial prominence. Venus possesses distinct characteristics that set it apart from other planets in the solar system. It harbors a feeble-induced magnetosphere and boasts an exceptionally thick atmosphere primarily composed of carbon dioxide. This dense atmosphere, coupled with a global sulfuric acid cloud cover, creates an extreme greenhouse effect. Consequently, the surface of Venus experiences an average temperature of 737 K, 464 degrees Celsius, 867 degrees Fahrenheit, and an overwhelming atmospheric pressure 92 times that of Earth at sea level. These conditions transform the air into a supercritical fluid. However, at higher altitudes of approximately 50 kilometers, 30 miles, the pressure, temperature, and radiation resemble those found on Earth's surface. Scientists have identified potentially favorable conditions for life within the cloud layers of Venus. Recent research has unveiled suggestive evidence, although not conclusive, of the presence of life on this planet. Early in its history, Venus may have even possessed liquid surface water, possibly forming oceans. Unfortunately, the runaway greenhouse effect eventually caused the evaporation of any water, which was subsequently swept away into space by the solar wind. Internally, Venus is believed to consist of a core, mantle, and crust, with volcanic activity shaping its surface through extensive resurfacing, unlike Earth's plate tectonics. Unlike most planets in the solar system, Venus lacks any natural satellites or moons. It exhibits a retrograde rotation, meaning it spins against its orbital direction, which is further slowed by the strong atmospheric currents and drag. As a result, a Venusian solar day lasts 117 Earth days, making it the longest solar day in the solar system. Completing an orbit around the Sun takes Venus 224.7 Earth days, resulting in a Venusian year that is slightly less than 2 Venusian days. The orbits of Venus and Earth have the closest approach among all planetary pairs in the solar system, occurring at synodic periods of 1.6 years. While this proximity allows for closer encounters during inferior conjunction, Mercury, being the most central planet, remains, on average, closer to both Venus and Earth and has more frequent encounters. Nonetheless, Venus and Earth exhibit the smallest difference in gravitational potential between any two planets in the solar system, making Venus an accessible and attractive destination for interplanetary missions and gravity-assist maneuvers. Venus played a pivotal role in space exploration history. In 1961, it became the target of the first-ever interplanetary flight, and subsequent missions achieved significant milestones, including the first soft landing on another planet in 1970. These endeavors shed light on the drastic greenhouse effects and oppressive surface conditions of Venus, providing crucial insights into global warming predictions on Earth. Consequently, interest in the once popular theories and science fiction narratives surrounding Venus as a habitable or inhabited planet diminished. However, crewed missions to Venus have been proposed either for flybys to facilitate faster and safer travel to Mars using gravity assists or for atmospheric entry and sustained flight at altitudes where conditions closely resemble Earth's surface, surpassing anywhere else in the solar system. Physical aspects. Venus, often referred to as Earth's sister or twin, is one of the 4 rocky terrestrial planets in our solar system, sharing similarities with our own planet. It closely resembles Earth in terms of size and mass. With a diameter of 12,103.6 kilometers, 7,520.8 miles, Venus is only slightly smaller than Earth, differing by a mere 638.4 kilometers, 396.7 miles. Its mass accounts for approximately 81.5% of Earth's. Due to its slow rotation, Venus has acquired a nearly spherical shape. However, conditions on the surface of Venus are vastly different from those on Earth. The planet's dense atmosphere consists primarily of carbon dioxide, making up 96.5% of its composition, with the remaining 3.5% composed of nitrogen. The surface of Venus experiences a staggering surface pressure of 9.3 megapascals, 93 bars, and maintains an average temperature of 737 K, 464 degrees Celsius, 867 degrees Fahrenheit. These extreme temperatures surpass the critical points of both major constituents, rendering the surface atmosphere a supercritical fluid consisting mainly of supercritical carbon dioxide, along with some supercritical nitrogen. Atmosphere and climate. Venus possesses a dense atmosphere primarily composed of 96.5% carbon dioxide and 3.5% nitrogen. These gases exist as supercritical fluids at the planet's surface, with the added presence of traces of other gases such as sulfur dioxide. The mass of Venus's atmosphere is 92 times that of Earth's, resulting in a surface pressure approximately 93 times greater than that of Earth, a pressure equivalent to being nearly 1 kilometer (5/8 mile) deep underwater on our planet. The density of the atmosphere at the surface is 65 kilograms per cubic meter, 4.1 pounds per CUFT, 6.5% that of water, making it around 50 times denser than Earth's atmosphere at sea level and 6.5% as dense as water. The abundance of carbon dioxide in Venus's atmosphere contributes to the most potent greenhouse effect in the solar system. This effect leads to surface temperatures of at least 735 K, 462 degrees Celsius, 864 degrees Fahrenheit, surpassing the temperatures found on Mercury, despite Venus being almost twice as far from the Sun as Mercury. Venus receives only 25% of the solar irradiance that Mercury receives. The extreme greenhouse effect on Venus has drawn attention from scientists like Carl Sagan, who consider it a warning and a subject for studying climate change on Earth. Venus's atmosphere also exhibits a higher concentration of primordial noble gases compared to Earth's atmosphere, indicating a divergence in evolution between the two planets. The enrichment is attributed to factors such as a significant common impact or the accretion of a more substantial primary atmosphere from the solar nebula. However, the atmosphere lacks radiogenic argon, which suggests an early cessation of major magmatic activity. Studies suggest that billions of years ago, Venus may have had an atmosphere similar to Earth's early atmosphere, potentially harboring significant amounts of liquid water on its surface. Over time, solar forcing from the increasing luminosity of the Sun and large volcanic resurfacing led to the evaporation of the original water and the transformation of the atmosphere into its current state. The addition of greenhouse gases, including water, eventually triggered a runaway greenhouse effect. While the surface conditions on Venus are no longer conducive to Earth-like life, speculation remains about the possibility of life existing in the upper cloud layers, where atmospheric conditions resemble those on Earth to a greater extent. Temperatures in these layers range between 303 and 353 K, 30 and 80 degrees Celsius, 86 and 176 degrees Fahrenheit, with pressure and radiation similar to Earth's surface but accompanied by acidic clouds and carbon dioxide-filled air. The potential detection of phosphine in Venus's atmosphere raised speculation about the presence of extant life. However, subsequent research has attributed the signal to sulfur dioxide or found no evidence of absorption lines associated with phosphine. Despite Venus's slow rotation, the thermal inertia and heat transfer by winds in the lower atmosphere prevent significant temperature variations between the planet's two hemispheres, regardless of whether they face or do not face the sun. Surface winds are sluggish, moving at a few kilometers per hour. However, due to the high atmospheric density, these slow winds exert substantial force against obstructions and transport dust and small stones across the surface. The combination of extreme heat, pressure, and the absence of oxygen makes it incredibly challenging for humans to navigate the Venusian environment. Venus temperature. Above the dense carbon dioxide layer, Venus is shrouded by thick clouds consisting mainly of sulfuric acid. These clouds form through a chemical reaction involving sulfur dioxide and water, resulting in sulfuric acid hydrate. Additionally, the clouds contain approximately 1% ferric chloride, along with potential constituents such as ferric sulfate, aluminum chloride, and phosphoric anhydride. Different cloud levels exhibit varying compositions and particle size distributions. Similar to Earth's thick cloud cover, these clouds on Venus reflect about 70% of the incoming sunlight back into space. Their extensive coverage obstructs visual observation of Venus's surface, making it challenging to study directly. Despite being closer to the Sun than Earth, Venus receives significantly less sunlight at the surface, with only 10% of the incoming sunlight penetrating the cloud layer. Consequently, average daytime illumination on the Venusian surface reaches levels of around 14,000 lux, comparable to an earthly overcast day. The cloud tops experience powerful winds, reaching speeds of 300 km per hour, 185 miles per hour, circumnavigating the planet every 4 to 5 Earth days. Venusian winds can reach speeds up to 60 times faster than the planet's rotation speed, in stark contrast to Earth's fastest winds, which are only 10 to 20% of its rotation speed. Space age. In the realm of interplanetary exploration, humanity achieved its first milestone in 1961 with the Soviet space probe Venera 1, part of the Venera program, which aimed to reach Venus. Unfortunately, contact with Venera 1 was lost during its journey. 206, however, the United States Mariner 2 mission, launched as part of the Mariner program, successfully accomplished the first interplanetary mission by passing 34,833 kilometers, 21,644 miles, above the surface of Venus on December 14, 1962. Mariner 2 gathered valuable data about Venus's atmosphere, 207-208. During the 1960s, scientists conducted radar observations of Venus, providing the first measurements of its rotation period, which closely matched the actual value, 209. In 1966, the Soviet Union's Venera 3 became the first probe and lander to impact and reach another celestial body besides the Moon. Regrettably, it couldn't transmit any data as it crashed into Venus's surface. The following year, Venera 4 successfully deployed scientific experiments in the Venusian atmosphere before meeting a similar fate. It revealed that the surface temperature was much hotter than previously calculated, reaching almost 500 degrees Celsius (932 degrees Fahrenheit), and the atmosphere was composed of 95% carbon dioxide, CO2. Additionally, the density of Venus's atmosphere exceeded expectations, 210. In a noteworthy example of early space cooperation, data from Venera 4 was combined with the 1967 Mariner 5 data. A joint Soviet-American science team analyzed this information in a series of colloquia over the following year, 211. On December 15, 1970, Venera 7 accomplished a significant milestone by becoming the first spacecraft to softly land on another planet and successfully transmit data back to Earth, 212. In 1974, the Mariner 10 mission made use of an interplanetary gravity assist from Venus to redirect its trajectory towards Mercury. During the flyby, Mariner 10 captured ultraviolet photographs of the Venusian clouds, unveiling the remarkably high wind speeds in its atmosphere. This marked the first utilization of the interplanetary gravity assist technique, which would be employed by subsequent space probes. Radar observations in the 1970s provided the first glimpse of Venus's surface details. By beaming pulses of radio waves using the Arecibo Observatory's 300-meter, 1,000-foot radio telescope, astronomers discovered two highly reflective regions known as the alpha and beta regions. They also identified a bright area believed to be mountains, named Maxwell Montes. Interestingly, these three features are the only ones on Venus without female names. 97. In 1975, the Soviet Venera 9 and 10 landers transmitted the first black and white images from the surface of Venus. NASA's Pioneer Venus project, consisting of the Pioneer Venus Multiprobe and Pioneer Venus Orbiter missions, provided additional data from its orbit around Venus between 1978 and 1992, 214, 215. In 1982, the Soviet Venera 13 and 14 landers captured the first color images of the Venusian surface. The ancient Maya regarded Venus as the most significant celestial body after the Sun and Moon. They named it Chekeg or Noek, translating to the Great Star. The cycles of Venus played a crucial role in their calendar system and were described in texts such as the Maya Codex of Mexico and the Dresden Codex.